assuming we have our area which is rectangular, let's assume we have an example of our topographical map here. Let us have a simple illustration. The area here, assuming we have 90, 91, 92, 93, 94, we have 10, 11, northern, 12, 13, 15, etc. And then the area they're interested in, assuming it is this one. Let me use this. Just give you an example. Assuming the area was maybe a game reserve. So they want you to find the area covered by a game reserve. So as I told you, assuming they have given us our scale is 1 centimeter representing 50,000 centimeters. In most cases, our map extracts have this scale. East Africa, most of the maps have got 1 centimeter representing 50,000 centimeters as our representative fraction. And in most cases, the grid box, the grid square is, the side is 2 centimeters. Most of them, it is standard. However, they can vary. So don't cram that it is going to be 2 centimeters. The sides can vary. So supposing they have told you to find out the area covered by a game reserve. So as I told you, you identify the area. So our area is this one. This one, this one. This one is the area we are interested in. So we said that you find out what is the nature of the area. So when you look at this, our area, the nature is rectangular. Rectangular. So our area is rectangular in shape. So after knowing that, we should know what is the formula for this. The formula for finding the area of a rectangle is length times width. After knowing that, then you find out what is the map length. What is the map, the length on the map? Length. Get your ruler and measure the map distance for length from here up to here. I'm assuming, for me I'm going to use, because the grid box is 2 centimeters, that means the area, the side is 2 centimeters per square. This is 2, 4, 6, 8. So I'm assuming my length is 80 centimeters on the map. But for you, you can use a ruler to measure this distance from here up to here. Then my width, I'm going to get the ruler. Again, you measure from here up to here. Assuming you have measured from here up to here, and therefore 4 centimeters. So that is the length and the width. But we know that the area of a rectangle is length times width, which is going to be length, that is 8 centimeters, times width 4 centimeters. Length times width, that is what we get. So our map area, we can say map area, because this is not the actual ground area. You multiply here. 8 times 4. What do we get? 8 times 4, 32. 32 centimeters squared. That is the map area of our feature. But we are interested in finding out the actual ground area. We cannot get the actual ground area unless we know the area per grid square. We need to get the map area per grid square, because it is these are the small squares are the ones that make up the whole square. 1, 2, 3, 4, 5, 6, 7, 8. Small squares give us this. So now we find the map area per grid square, map area per grid square, per grid square. We know that a square, the area area of a square is S squared. Now, what is the side of a square? We have known that the side of a square is 2 centimeters. I've told you that in most cases it is 2 centimeters. So that means if the side is 2 centimeters, that means the area of a box is going to be 2 centimeters squared, which is going to give us area of a grid square is 4 centimeters squared. That is in the map area per grid box. Every grid box is 4 centimeters squared. But that is not the point. This one is driving us to finding the actual ground area. I told you they are interested in finding the actual ground area of the game reserve, for example. So now after finding the map areas, now we have the map area per grid box and we have the map area of the feature. Now we are going to finding the actual ground area of the feature, but you cannot get this unless you know the actual ground area that is represented by a box, that every grid box represents which area on the ground. After getting that area that is represented by a small box, then we can add up all those small areas to find out the area that is represented by this feature, which is of this area. Now what we do, we know this, but now what is the actual ground area per grid box? This is the map area per grid box. Now we want actual ground area per box, per grid square, not map. How do we get this one? We know that the area of a square is a square, the formula. That is known. But then we know that the side of a square is 2 centimeters. So here we are going to have area equal to 2 centimeters times 2 centimeters. But then we need to know, according to our area, every centimeter represents what? So we need to find out every centimeter on the map represents which distance on the ground. So given our area, given our scale, 1 centimeter representing 50,000 centimeters, this is representative fraction scale, representative fraction. So you convert this one from representative fraction into statement scale. So we need statement scale. So statement scale, given this, we know here you have to convert 1 kilometer. You have to convert from this one is in centimeters, convert it into kilometers, such that we can find out 1 centimeter represents what on the actual ground. This one, 1 kilometer equals 100,000 centimeters. If that is the case, how about 50,000 centimeters? We want to convert into kilometers. So here you convert, you know how to calculate this. So we shall have 1 centimeter to half a kilometer. Meaning every centimeter I see here, every centimeter on the map, on the ground it is half a kilometer. Because the actual ground distance cannot fit on this map unless it is scaled down. So after knowing that, so now we know that wherever I see a centimeter, I must put a kilometer. So our actual ground area per box is going to be 2. Where there is a centimeter, you put half a kilometer. 2 times half a kilometer. Meaning where there was a centimeter on the map, I've put actual ground distance, which is half a kilometer, which we have seen here. This one times this times 2 times half a kilometer. Where I put half a kilometer, that means there has been 1 centimeter, because here this is 2 times 1 times centimeter. So this is the same. Where there is 1, put half a kilometer. So here we are going to, this one is going to pass with this one. We shall have 1 kilometer. This one with this one, we shall have 1 kilometer. So meaning the area per grid box actual is 1 kilometer squared. Meaning every box here I see on the map, it is 1 squared on the actual ground. But on the map, it is 4 centimeters squared. So whenever I see 4 centimeters squared, there is 4 kilometers squared. Wherever I see 4 centimeters squared on the map, it is 1 kilometer squared on the actual ground. So after knowing this, so meaning now here we are going to actual ground area of the game reserve. That is where we are heading. We know that the map area here is 4 centimeters squared, and this one represents actual ground area 1 kilometer squared. That one we have seen. If that is the case, that wherever I see 4 centimeters, on the map it is 1 kilometer squared. Meaning here, if that is the case, how about 32 centimeters squared on the map? What is this on the actual ground? We can say let it be x. Cross multiply. We shall have 4 centimeters squared times x, which will equal to 32 centimeters squared times 1 kilometer squared. Here we shall, because we are interested in getting kilometers, we shall divide through by 4 centimeters squared, divided through by 4 centimeters squared. This one will disappear with this, we shall remain with x. Here we shall have this centimeter squared will go with this one. We shall remain with the 32 kilometers squared divided by 4. 32 kilometers squared divided by 4. When you divide here by 2, 16, by 2 once, by 2, 8. So we shall have our x equaling to 8 kilometers squared. So therefore, our area covered by the game reserve because is 80 kilometers squared. That is the area that is covered by the game reserve. But this one is alternative 1. Using this is alternative 1. So the first method we can use, we can first get the area, the map area of the feature. We get the map area of a grid square. Then we get the actual ground area of a grid square, and we use that one to find the actual ground area of the feature. That is 1. Then another method, we are going to see how we can find the area of an area shown on the map using another method.